One more example here. This is the second video for section 4.2. We're just going to do one example in this video. So let's go ahead and get these notes out that I provided. So I've got it typed out for you already. It says, let me read this here and then we're going to try to draw a picture. So it says a large helium-filled penguin. This might be Thanksgiving Day parade or something like that. Is stopped at the beginning of a parade route, awaiting the start of a parade. There are two cables attached to the underside of the penguin that make angles of 48 degrees and 40 degrees with the ground, and are in the same place as in the same plane as a perpendicular line from the penguin to the ground. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? Alright, so we want to know how tall the penguin is, how high above the ground it is. Okay, so first of all, draw a picture. Alright, now you don't have to draw a penguin. I doubt your penguin's going to be as good as my penguin, because here it is. Look at him. Isn't he perfect there? Yeah, there's my penguin. That was my attempt at it, at least. So let's try to let me draw the picture here. We got wires coming from the bottom here, and I'll just have the wires attached to one of his feet here. Okay, so here's the wire, and here's a wire as well. Okay. Now I drew him at that angle because it tells us the two cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground. So this angle right here with the ground, let me just draw the ground here. Let me try to make it horizontal. One more time. Okay, that's as good as it's going to get. So this right here is going to be 48 degrees, and this angle is going to be 40 degrees. Hopefully that makes sense. The closer you are, the bigger the angle of elevation is. Okay, I talked about that a little bit last time. So what I'm going to do, what we said is, it's going to be, these lines are going to be coplanar, these cables are going to be coplanar to a perpendicular segment here. Alright, so there's my penguin, and there's my drawing, okay, my two triangles. So hopefully that makes sense there, how I drew the picture based off of that information. Now, there's one thing I need to list, and that's right here, 10. Okay, 10 feet from each of the, sorry, they're 10 feet from each other. So let me go and write that down. So this distance is 10. Those cables are 10 feet away. All right. So that's all it gives us. It just gives us that little segment there, 10. I think it's 10 feet. I think that's right. Yeah, 10 feet. So we've got some things to find. We want to figure out how high this thing is above the ground. So let me call that h for height. Okay. And let me call the distance. There's one more thing maybe I want to mention here, and that is, well, the length of this side right here. So let's call that x. Okay. All right, so notice we've got two variables here, guys. So what we want to do, we want to figure out what h is, yes, but we also, well, we don't necessarily, actually, we might need to figure out what x is. Let's see where that takes us. So here we go. Let me first try to set up an equation here that tries to relate x and h and all this stuff. So let's think about this. Let's first start with this 48-degree angle. Okay, that 48-degree angle. Notice the smaller triangle here, the one I'm going to highlight in green. This triangle right there. It's a right triangle. So one way I can relate h and x, I could kind of link them together here. Talk about a relationship. Is to use another trig ratio. Hopefully you notice what we've got here. So if I've got this 48-degree angle, and look at h and look at x, what's the relationship between this 48-degree angle and h? Is that the opposite side, is that the adjacent side, or is that the hypotenuse? Well, that's the opposite. Okay? Now, x is going to be the adjacent side. So if we've got the opposite side, or we want to find the opposite side, we also want to find the adjacent side. Which trig ratio do you think we should use that deals with opposite and adjacent? And again, just like the last two examples, it's going to be tangent. Now, tangent is not always going to be the trig ratio you use, but in this case, yeah, the tangent of 48, that's going to equal h over x. All right. The reason it's h over x, guys, h is the opposite x is the adjacent. Tangent's always opposite over adjacent. Okay, so guys, you notice we've got two variables, right? So, are we going to be able to solve that one equation for those two variables? The answer is no. We can't solve that one equation if it has two variables in it. We have to have two equations. So let's try this. So we've got that. That's true. Now I'm going to try to set up another equation that relates h and x together, but let's use the big triangle now. Okay, and let's use the other angle. So the big triangle I'm talking about is from there to there to there. All right, so that triangle I just highlighted in red. So I want to use the angle that I'm given, not the 90 degree, but the other one here, 40. Okay, let's use the angle I'm given for that triangle. So that's going to be 40. Now again, I want to relate h, and I want to have h and x involved in this equation as well. Okay, I want to have the same two variables involved. So I'm going to use tangent again. So tangent of 40 is going to equal h over, well, that's h is the opposite still, isn't it? So what's the adjacent? What would this whole side be? It's going to be 10 plus x, or x plus 10, whatever you want to call it there. So I need to solve one of these equations for one of my variables. If you remember from algebra, I can't remember if it was 1 or 2. You guys have done systems of equations here, solving equations with two variables. Okay, you need two equations in order to do that. So in this case, I'm going to use substitution. All right, we had two methods that we mentioned a lot: substitution and elimination. Hopefully that sounds familiar. Let's try to use substitution. Now, if we use substitution, we need to solve for one of the variables. Okay, we need to get h equals or x equals. And I'm going to try to do the easiest one that's up here. Okay, try to make it as easy as possible myself. So what I'm going to do is I'm going to solve for h in this equation. Okay, so let's try to get h by itself in this equation. Well, in order to do that, h is being divided by x right now, so I want to get rid of that division by x. What do we do to move that over? The answer is multiply by x. So we know x times the tangent of 48 is going to equal h. Alright, so guys, I'm going to use that now, and I'm going to plug that into this equation to try to help me solve. Okay? So I know h is equal to this whole stuff right here. So I'm going to plug that whole stuff in for h into that equation. And then you'll notice we'll only have one variable now, and we should be able to solve that. So let's do this. I'm going to write it in red now. So we know the tangent of 40 is going to equal, instead of h, I'm going to write x times the tangent of 48. Okay? And then it's going to be divided by 10 plus x. So let's keep it going. Now, the next thing I want to do is, well, I've got a fraction here. I'd like to get rid of fractions, not have to work with them. So if I want to undo this denominator, division by 10 plus x, how do I undo division by 10 plus x? Well, I multiply by 10 plus x. Both sides. Whatever I do to one side, I've got to do to the other. Okay, so those will cancel, those will cancel. So we're left with 10 plus x times the tangent of 40 is equal to x times the tangent of 48. Okay. Alright, those divide to equal 1, so that's why I say they quote unquote cancel. Right, 10 plus x divided by 10 plus x is 1. Alright, so here it goes. What you could do here is distribute, but I want to make it as easy as possible myself. So rather than distributing tangent of 40, it would get kind of messy if I did that. Let me just divide by tangent of 40, because that's being multiplied, right? It's 10 plus x times tangent of 40. So I want to just go ahead and move it over here and just divide by it. So I don't have to worry about distributing. Those are gone when I do that. So we get 10 plus x. Now, what I would do is just in your calculator, I would go ahead and get the decimal form for this. Again, just to reiterate, we're talking about degrees here, so make sure your calculator's in degree mode. So tangent 48 divided by tangent 40, enter. I got 1.32. Alright, hopefully you guys got the same thing. And I'm forgetting about this x here. All I did was tangent 48 divided by tangent 40. That's 1.32. That's going to be 1.32x. This is easy to solve, isn't it? Alright, so what we can do from here is we got to try to isolate x, get x on the same side of the equation. So in order to undo this plus x, all I got to do is subtract x. Cancel. We got 10 is equal to, it's going to be, if you got 1.32x minus 1x, so what's 1.32 of those guys minus 1 of those guys? The answer is 0.32 of those guys. Okay. So 0.32x. And then what I need to do to get x by itself is what? This is 0.32 times x. In order to undo 0.32 times x, we have to divide by 0.32. So take 10 divided by 0.32, 31.25 the x. Let me just double check, just to make sure I've got this right. I don't want to end this. Oh, shoot. Okay, my answer is a little bit off. The reason it's a little bit off is because I rounded too much. Okay, so the answer they have, the book has, is 34.32. So to make sure you're not off by that much, you shouldn't round. You should just keep it in your calculator. So right here, let me just do this real quick. So tangent of 48 divided by tangent of 40. I'm going to keep that decimal in my calculator, and then I'm going to subtract 1 from that, and then what I'm going to do is I'm going to take 10 divided by that answer, 30.9. Let's see. Hang on. Hang on. Is there something I did wrong here? Alright, I'm going to rewatch this video. If I don't make a correction here, I'm just going to leave it. If I don't find anything, then it means I did it right. I just had some rounding issues, I think. If I do make a correction, obviously, I made a mistake somewhere. If I adjust this video. So remember, kids, life goes on long after the thrill of living is gone.